This is where we were in our last video. Alright? Now, here, we have what we did in our last video was to look at two vectors, two dimensions, and we saw that the scalar product of two vectors is also called the dot product. And what it tells us is how much one vector is helping the other vector. Alright? How much of one vector is pointing in the same direction as the other vector, helping it out. Alright, now we want to see something here. Suppose we have three-dimensional space now. Let us say we have our x plane, our y plane, and our z plane. Alright. Now, in this case, we have a vector. Let's say this vector is OA. So the vector is OA. Now, this being vector OA, what we're saying is that A is here and it's a certain distance above the floor. This is the floor. It's a certain distance in the x direction above the floor. But let us say going in the x direction, you have a unit vector I, a unit vector in the x direction. Alright, this is the origin O. How far is it in the y direction? If you look at this distance, that's how far it is. Now remember, you see the I, it's this distance here. It is in the x direction. I is going this way, is pointing this way. Now we have J pointing in the y direction this way. Alright? And then it is a certain distance above the floor. Right? Let's go against the wall here and we do this. So how high up it is? It is in the k direction. K is up. Alright. So there we have our vector OA. Now our vector OA, let's write it like this. OA, vector OA is equal to, let's say, a portion of OA in the x direction is A1, and the x direction mean is pointing in the unit direction of unit vector I. So ij and k are showing the directions of it. There's a component of OA in the x direction that we call A1, and I will show that is in the x direction. Right? So going this way. Now this distance right here would be A1. Alright? Right here would be A1. Plus, then we have, say, B1J. B1 is in this direction, the y direction. B1 is this one from the origin out here, and is in the j direction, which is same as y direction, but we call it j as a unit vector, plus c1. Now c1 is this distance here from floor to ceiling, and it's in the z direction, so let's call it k, a unit vector k. Alright, I won't bother to draw the lines like this because it will crowd the screen too much. Now suppose we have another vector. Let's say that other vector comes somewhere out here, and let's call it b. So we have OB. Now the part of OB, that the length of OB in the x direction, let's call it A2, and in the x direction unit vector is pointing I, plus in the y direction we have B2, and the y direction shows unit vector is J, plus in the z direction let's call it C2, and K is the unit vector that points in the z direction. Alright, so we're going I, J, K. If we start from the origin, go to the left I, then in the x direction I, where I is pointing, then in the y direction where J is pointing, the length of that portion of the vector OB, then the portion of the vector OB that's pointing upwards in the z direction where the K is pointing would touch the end right here of B. See that? Now here, you know from what we said before that OA dot OB is equal to length of OA dot, let's say this is length of OB cos theta. Alright? Now let us look at these and multiply them, because we imagine we're multiplying two vectors now. Now when you multiply a number, multiplying vectors now, and see what the dot product, scalar product, right, will be like. So OA dot OB is going to be what? It's going to be AI plus A1I plus B1J plus C1K, right? And that is multiplied by, you have A2I plus B2J plus C2K. You see that? All right. Now, if we multiply these out, we get A1I times A2I. So we have A1, A2, II, all right, T there, II, plus B1J. Oh, let's continue with this. A1I by B2J is going to be A1I by B2J. Let's write it like this. A1 B2 times IJ. Alright? Or here now. Alright. I'm thinking, let's just write it out exactly as it is first, to keep the concentration. We have A1I, A2I. That's A1I by A2I. See that? Plus A1I by B2J. So what we have is A1I, B2J. See? Plus A1I, C2K. So we have A1I, C2K. Alright? Plus, alright, let's continue below. B1j time now to multiply. B1j times A1I. So it's B1j A1I plus B1j times B2j. So it's B1j B2j plus we have B1j by C2k. So we have B1j C2k. See that? Plus, alright, after this now, C1k times A2i. So we have C1k times A2i plus C1k times B2j. So we have C1k B2j plus, then we have C1k by C2k. So we have C1k by C2k. See that? Equals. Alright. Now, here, let's put what you might call the like terms together, the ij's, and so on and so forth. So we have A1, A2, then we have II. Let's use a different color. II. My gosh, I keep writing T. Plus. Then we have A1, B2, and then IJ. Alright, this one. Then we have A1, C2, and then IK, which is this one. See that? Plus, we have A1, B1, IJ, plus, then we have B1, B2, JJ. Oh no, I messed up that one. B1, B2, JJ, plus, then we have B1, C2, JK, plus, oh, didn't write the JK, another color, JK, plus, then here, A2C1, A2C1, KI, plus, putting them in alphabetical order, B2, C1, then KJ, plus, then C1, C2, KK. Alright. So now, how do we simplify this? Guess what? You see, II, both of them are pointing in the same direction. The angle between them is 0. See that? So I in that case, cos of 0 is 1. So I amounts to 1. You see JJ, they're both of them in the y direction. So JJ is also 1. It's the same direction. As for KK, same direction too. Both of them are pointing up in the Z direction. So that's 1. Alright, I and J. What about IJ? Well, you see I is going this way and J is 90 degrees from it. Cos 90 is 0. So IJ is 0. You see, what else we have? We have ij, we have ik. I is in the x direction and k is up, and they are 90 degrees apart, so ik is 0, right? And then kj, k is acting up, j is acting in the y direction, 90 degrees, jk is 0. Alright? That's 0 there. So now, what we have here is this. A1, A2, II, that's gone, you know. So over here, A1, A2, II is 0. Plus ij is 1. So it's A1, B2. See that? It's A1, B2 plus what happened with this one? It's 1. Right? So A1, the ik is 1. So A1, C2 is there. So we have A1, C2 plus all right. What else do we have? So A1, A2 is II, good, times, oh, my mistake, I forgot, the II is 1, I'll mix it up. Alright, so let's repeat this and keep, don't take any shortcut yet. A1, A2 times 1. Alright, so A1, A2 times 1, good, plus ij, this is going to be 0, you know, ij is 0, so A1, B2 times 0, alright, plus A1, B2 times 0 plus, or let's not put the times because it's kind of crowding. We already have a lot of writing on the screen. Don't want to be too overcrowded. So this is 1, this is 0. Let's just write the 0 and the 1 and leave out the multiplication sign. Plus A1C2 is going to be ik is 0, so that's 0. So A1 C2 0 plus what happened down here now? A1 B1, but A1 B1 here is going to be, it's a 0 here. Let me see something here. A1 A2, A1 A2, A1 B2, A1 C2, good. After that B1 A2, so I have A1, just checking something, A1 A2 II plus A1 B2 ij plus A1 C2 plus B1 A2. Oh, it's B1 A2 this should be. My mistake there. It's B1 A2. Alright, just finish checking. B1 B2, then B1 C2. Okay, and then after that I have C1 A2, C1 B2, C1 C2, Alright, just double checking something. I identified a mistake there. Alright, so we continue. So you see A1, A2, II, A1, B2, IJ, A1, C2, IK. Good. Then B1, well, A2, this should be A2, as I corrected earlier. This should be A2. So it's A2, B1, IJ, B1, B2, JJ, B1, C2, JK, then A2, C1, KI, B2, C1, KJ, then C1, C2, KK. Alright, now here A1, A2 times 1. A1, B2, 0. A1, C2, 0. Right. And then after this, A2, B1, IJ. So it's A2, B1, IJ is 0 plus B1, B2, JJ. So JJ is 1. B1, B2 times 1 plus, and then B1, C2, JK. So we have B1, C2, but JK is 0 plus, and then what happened below here? A2, C1, KI, but that's 0. So A2, C1, 0 plus, then we have B2, C1, KJ, which is 0. So B2, C1, 0 plus, and then C1, C2, KK. KK is 1, so it's C1, C2. C1, C2. Now here, all the 0 parts disappear. So we have A1, A2 plus A2, plus B1, B2. So we have this part, and then this part, then plus C1, C2, this part, because there would be a 1 here, alright? So C1, C2. So A1, A2 plus B1, B2 plus C1, C2. So what happened here is that we have A1, A2 plus B1, B2 plus C1, C2. Everything else cancel, right? So you see that? So all we do is just multiply each of these terms together, right? So that's what we have there. That is the dot product of two vectors, right? So of course also called the scalar product. That's the scalar product or the dot product of two vectors.